YouTube. Uh, so sorry. I'm starting to stream now, Shelly. I really apologize for that. I didn't set up the streaming before. Okay. Um, you didn't miss much. Trust me. No, you missed it quite a bit. I'll just for the people who are streaming, I'm gonna just quickly recap what I covered. I said there's a whole bunch of headers that you can use to prevent the browser from doing certain things. For example, you can tell it how to handle cookies, how to handle certain cross-origin requests, and this whole class of security policies. And I'm going to kind of talk about all of these again in a second, a little bit. So you can tell the browser where it is allowed to load script styles, images, fonts, and so on from, and where you can where the web page can submit forms, what kind of plugins are allowed, and so on and so forth. Okay, quick summary. All right. So let me demonstrate for you then how I am using them in my vulnerable demo application. So in my vulnerable demo application, I have now activated all of these headers using the secure headers gem. It is a very quick way in which you can activate all these headers. Okay. The cookie headers, I may have to do something extra. I'll show you later. Okay. So for example, I've told the browser, check the response you're sending to the server side. If the response, like if it's a form and you're submitting a form, check the form to see if there's something in there that looks like a script. The browser is going to be much more capable of identifying a script than you are as a backend developer, because the browser executes scripts. So if the browser detects something that's executable, that's great. The browser can do that for us. And it says block anything that looks like a script from coming in. Okay. This says do not allow other websites to embed my website within a frame. Okay. This refer policy says, when I set it to origin, when cross origin, this says only report the domain name of my website if the user goes to another website, because another website can say, hey, which website did you come from? Don't tell them the full path that the browser is coming from. Only tell them the host name. All right. And then here are all my content security policies. All right. So this is, I won't go through all of them. I'll give you some documentation you can read. So this is, for example, saying any scripts, any JavaScript running on my website must be either loaded, self means it must either come from my website or it must come from one of these sites that I'm specifying. And notice I'm specifying HTTPS on them as well. So no other JavaScript is allowed to run on this website. Styles, I'm allowing unsafe inline just as a demonstration. In my Credence application, I don't allow this. Okay, so I'm saying allow styles to be embedded in the HTML, but this is really a bad policy. I should not allow that. Okay, forms, only allow forms to be submitted to my own website, not to any other website. Okay. Okay. So on and so forth. All right. This one, block all mixed content, means don't allow some of the content on this website to be HTTPS and some to be HTTP. They must all be the same type, which is going to be HTTPS. Right? It prevents some resources being injected which are only insecure. And last of all, like I said, my favorite one, if any of these policies is being violated by the web page you're trying to render, please send a post request to my web application to this route and tell me what's going on. And then I've got a post route where if a violation is reported, I'm basically gonna just log that. Okay. All right. Let's see what happens in my website now that I've set all of these to set all these protections. So let me run my previously vulnerable website that's much stronger now. And let me go to the, let me go try it out again. So remember, I can type in, here is my secret. No problem. Everything's good so far. By the way, Let me quickly do, where is it? Safari, where are you? Where is the console, JavaScript console? Right? Okay. I'm basically telling it, please, I want to see any errors that are detected here. All. Okay. So now let's try to do something dangerous. Let's try this demo script. Okay. Remember, I told it scripts can only be loaded from my web application or from like Bootstrap or something like that, not inline. So let's see if it catches it. So when I do it this time, whoa, the pop-up didn't show. Instead, you'll notice down here, a couple of errors are showing up in my JavaScript console. So the browser is detecting these errors. These are typically not shown to the user, or sometimes they are. Sometimes you'll see a little icon somewhere. In fact, I wonder if I close this, if I close this, does it show me that there are errors? No, it doesn't show me that there are errors. That's terrible. Okay. Okay. So, but if I open up the console, it tells me that there are errors. The errors it says is that cross-site scripting auditor refuses to execute a script. I'm sorry if you may not be able to read this, and I cannot make it bigger. And does zooming in help at all? Does this help at all? Does it get bigger on your screen? Yes or no? No, not really. Okay. A little bit, right? It gets a little bit bigger. So this XSS auditor refused to execute a script because the source was found within the request, because its source code was found within the request. The server has sent an XSS protection header requesting this behavior. So I've told it to prevent this kind of behavior. Refuse, and that was one of my headers. My content security policy also caught it. It said refuse to execute a script because its hash, its nonce, or unsafe inline does not appear in the script source directive. So I have not provided any indication that you're allowed to run scripts that are inline to the HTML, that are embedded in the HTML. Okay. So it refused to run that script, and it doesn't show the script either. What's more is if you now look at my terminal where I was running this web application, you will notice now that my logger has logged CSP violation. And it tells me that this is your policy. Unfortunately, it doesn't tell me exactly what was violated, but it does say, oh, maybe it does. Let me see. Let me look at the report clearly. This is a big JSON that the browser sends back to me. All right, and it says there's a report, content security policy report I need to send to you. This location, okay, reported this violation, and it reported that there's a violation of script source. And I have set up script source to be self or jQuery or Bootstrap. So this is being violated, all right? And then it tells me some other directives as well and the status codes and stuff like that, okay? But it's telling me here that script source is being violated. Great. My browser actually not only blocks the attack, it even contacts my website now. It has sent me a post request to this report CSP violation, which I told it to report to, reporting the violation. So it provides me a full report of what went wrong. Okay. So these are all examples. So this is how you can use headers, and also one of the special headers is this content security policy to kind of block these types of attacks. All right. So one bit of good news is that these headers, for example, these ones, have largely prevented major cross-site resource forgery attacks in the last 5 years, roughly. In the last 5 years, cross-site resource forgery, like if you look at the list, if you look at like OWASP or maybe some security organizations that maintain a list of top most popular attacks, cross-site resource forgery has kind of dropped down the list considerably just because of these headers. A lot of them prevent people from sending cookies or performing actions on other websites that are trying to link to your website. Okay, and these CSP headers also have prevented a lot of cross-site scripting attacks, but not all. And I'm not sure why not all, but I think part of it is because when you're running JavaScript in a browser, when you're running code in a browser, there's so many types of vulnerabilities out there. It's crazy. So we just have to live with it as long as we allow JavaScript to run on browsers. There are still ways to kind of break in. One possible way, for example, can be if you have a plugin or an extension that is being attacked rather than the browser itself. Okay. All right. Okay. All right, so there's that. Any questions on this stuff? All right, let me just talk about how I've implemented them this week in my code. So this is going to be the easy part of this week's assignment. I forgot to tell you where, but this is in my web application, not my API. This is in my web application now. I've set up this gem called Secure Headers. All right. And I have now made a new controller called security.rb. So let me show you that. So I've created in my controller list, I've got a new controller called security.rb. Let me zoom in a little bit so if it help make it more readable for people. And security.rb basically has all these policies built into it. And I just wrote it as another controller. I don't have to do anything special. Okay. You can pretty much copy and paste this file and it should work for you as well. Okay. A couple of things I want to note. I did move a couple of things into this security.rb controller. In particular, I moved in, let me see if I can find it, from environments.rb. Previously, I had, where can I find it? Previously, I had the rack SSL enforcer. This is the thing that was enforcing, let me show you, it was here again. Where's rack SSL enforcer? Previously, I had this rack SSL enforcer for production mode, which forces browsers to use HTTPS. It does not accept, or it redirects them if they're trying to use something other than HTTPS. Okay. This week, I have moved that into security.rb because I want to put all my security stuff into one controller file. Okay. So you'll notice that a rack SSL enforcer with the configuration for production has been moved into security.rb. Okay. Otherwise, here's the rest of security.rb. I need the environments of the multi-route plugin for reasons you'll see. I'm setting up a couple of arrays. I'm making them constants with the locations of the domains that I'm using for fonts, scripts, and styles. These are all of these are loaded in my layout.slim. Okay, so if I look at layout.slim, so here is where I was loading Bootstrap, the style sheet for Bootstrap. Actually, it's a themed version of Bootstrap. Here's where I was loading the style sheets for Font Awesome. Font Awesome is the fonts that I'm using to create, for example, the GitHub icon and certain other things, certain other icons on my website. Font Awesome is just super. And this is where my scripts are. I'm using the Popper script for pop-ups, and Bootstrap uses the Popper script actually. So you got to load it yourself. And here's Bootstrap. Okay, the Bootstrap JavaScript. So the style sources and the script sources are all defined here. Okay, and when you look down it, so this is where I set the cookie headers. But I mentioned before that for some reason these cookie headers, were not working when I set it up this way. So to be doubly safe, I went into environments.rb, and when I set up my oh when I set up my when I set up my session information, I'm using Redis or whatever I'm using. I'm specifying here again that the cookies should use the HTTP only header and the same site header. Okay. Um, so this is like a bit of a duplication because this is already in my security.rb, but for some reason it only worked when I added it to my environments.rb. So you may want to look at why that's, I may want to figure out later why that's happening. So these are the, some of the cross-site origin headers. And then these are the content security policies that I'm setting up, okay? So you see, for example, I'm telling it images can only be loaded from my website, not from other websites, okay? Why? What's wrong with images? You may think an image is a harmless thing, but a browser doesn't know that an image link is actually loading an image until it gets the image. It's entirely possible that somebody can use an image link to do a cross-site forgery attack. Like they set up an image tag and they set the image to be some other website's, to be another website's address, but it's not really an image. It's just a GET request to some dangerous resource on that site. So people can use images in a dangerous way. So you should limit images to be only from your website or from a content distribution network that you trust. The fonts, the scripts, and the styles, I'm basically creating an array with the word self in it, and I'm adding these constant arrays to it so that it joins them together. Okay, so on and so forth. Notice there might be other sources that I've forgotten here. Default source says, if I have forgotten to specify the source of a certain type of asset, then by default, it should be self, which means this website only. Okay. Last of all, report any violations to this place. And here's my security route. So I made a new route called security/report CSP violation. All right. So that's all I had to do. You literally need to copy and paste that file into your application, and that should work. Okay. Okay. All right. The last thing that I want to mention, I think, is this content distribution network. I am loading scripts and fonts and styles from the content distribution network. I generally trust the content distribution network because they're pretty famous and they shouldn't screw up. But what would happen if somebody hacked into one of these content distribution networks and changed some of the scripts or style sheets, right? Then I would download some hacker's JavaScript and I would be running it on my application. That's super dangerous. And my content security policies wouldn't block them because I've said trust that CDN. This may seem like not such a legitimate form of attack, but it's increasingly becoming likely that a problem like this can happen. So you got to make sure that the scripts that are sent to you are the original scripts that you are expecting. And the way to do that is this. What I'm doing this week is, if you look at my layout.slim, now every time I link to a style sheet or I load some JavaScript, after the location of the style sheet or the script, I have another attribute called integrity. Remember integrity, one of the dimensions of security, data integrity? This says that the file that you should get, this CSS style sheet or this JavaScript file, if you hash it using SHA-384, it's 384 bit SHA, then this should be the base 64 version of the hash that you produce. Okay, so it's telling the browser, when you get the style sheet or these JavaScript, please hash them using SHA-384 and make sure that the base 64 version of the hash looks like this. Okay, So that ensures that if anybody is trying to modify one of these style sheets, since I set up my application like this, the browser will be able to catch it because the browser will hash it and detect, hey, this is not the same style sheet or not the same JavaScript that I was told to get. It doesn't match the hash of the content. All right. There's one more attribute called cross origin, which I've added to the end of each of these. And cross origin basically says if a outside style sheet or JavaScript asks to get cookies from this website, don't give it to them. All right. Do not pass my cookies onto any of these style sheets or JavaScript. They should not have access to my cookies. All right. All right. How should you get this SHA-384? There's a couple of ways. If you go, for example, let me just try to find it. Uh, so this is this. So let me go to Bootswatch and let me try to find my theme. Where is it? Not here. Let me try. Let me just go to Bootswatch and ask it. Let's see if I can find that theme again. Where is the search button? Oh, here it is. Cerulean. Oh, I'm so lazy. I took the first theme they had. Okay. So if I go to this theme, I think if I say download or preview, one of these pages should have, where is it? Where is it? This website should report to me. Let me go to download and let's say the minified CSS. No, it just wants to download it. Oops. There should be a place here where you can see the. Let me try it. Let me try it with. Let me try it with CDN with JS Deliver. Maybe JS Deliver does it though. JS Deliver. A lot of these content distribution networks, they tell you actually the hash you're looking for. So let me search for Popper. Okay, and let me make sure is this the one? Oh my God, there's so many. I think this is the one, right? So the project is at Popper.js core 292. So at Popper.js core 292, this one. And this should tell me, folks, where is it? If somebody has better eyes than me, this is the download button. This is the okay. I'm being stupid right now. There's got to be a place where it tells you the hash. If it doesn't tell you the hash, no problem. This is how I do it. You can literally hash it yourself. Okay, so at your command line, you can use curl to download. Oops, why can't I not select it? You can use curl to literally download, the JavaScript or the CSS file. You can pipe it through OpenSSL, which is a Unix library, and ask it to do a SHA-384 hash on it and give you the digest in binary format. And then you can pipe it again through OpenSSL and tell it to encode it as base64. Okay. And this is such a handy, helpful thing to be able to do for like both my links and both my scripts that I went ahead and created a little rake task that does it for me. So I've got a rake task called URL integrity, and you run it like this. You say rake URL integrity, and then you say URL equals to, and you provide any URL you want. And it'll run this whole command and provide you the SHA-384 hash for it. Okay. So for example, if I go back up to my layout and let's say I take this well, let's take this CSS file. You could do any file on the internet actually. Okay. And I can do rake URL integrity and URL equals, and I provided that the link to that file, and it will run that whole thing, and it'll tell me here's the SHA-384 for it. Okay, and I simply go ahead and I put that in the integrity attribute. All right. So you can take a look at my rake file. I do that automatically by myself. So whether the CDN provides it for you or you compute it by yourself, no problem, but do this, okay? And in fact, I believe increasingly, some browsers can even complain if you don't provide that integrity attribute. Some of them may actually give you a little, if you open up the JavaScript console, they'll have an error in there or a warning saying, warning, a CSS or a script was loaded for which no hash was provided, so I don't know what's going on. I don't know if it's safe or not, okay? So this is called sub-resource integrity. Sub-resource because this is a asset, or I should call it asset integrity, okay? For your style sheets, you can do this for your fonts, scripts, whatever you want. I'm doing it for my cerulean themed Bootstrap 5 style sheet. I'm doing it for my font awesome icons. I'm doing it for the popper JavaScript that creates pop-ups for me, models, I guess, for me. And I'm doing it for the Bootstrap JavaScript, which calls popper, actually. So for all of them, I've set up these integrities as well. Okay. Cool. Here is several resources for all the stuff that I've talked about. It will, if you're really interested in this, and you should be, I really recommend you to spend some time reading about these things, okay? So some of them describe, some of the basic headers that I did. I hope if any of these are not working right now, please let me know. But I hope all these, I've tried to edit all these, update all these websites. So these describe some of these basic headers and what they do, okay? Here's a link to content security policy and what each of them does, who supports it, etc. All right. So you'll notice some of the earlier headers have been deprecated or no longer work. So you have to kind of use the latest headers, okay? And it tells you in great detail what each one of these does. All right, so this is a great resource for that. Here's another one from Mozilla. Again, it gives you really great information about each and every single one of these and what they do. All right. And gives you some examples, what each of these keywords means, etc., etc. All right. Some more down here. This is similar to the earlier one I showed you, just, ooh, this doesn't work. Oh, I just updated that. Oh, I'm sorry. It's 2 lines long, but my PDF thinks it's just 1 line. All right. That doesn't work either. I got to fix this. I think it's somehow in pasting it, I broke it. In fact, I think if I just search that by itself, it should find it. I don't know why it's not working. Yeah, here it is. Okay. So using the same site to prevent CSRF attacks. And this goes into a lot of detail about how cross-site resource forgery is almost bye-bye. Like we don't have to worry about it that much anymore because of these powerful headers. If you're not using these headers, you're vulnerable though, okay? So, and largely that same site header that tells cookies, please don't share cookies if you're coming from another website, that largely takes care of CSRF attacks nowadays. I haven't checked this resource in a while. I hope it's still there on HTML5 and content security policies, but one more thing to read. Sub-resource integrity, another reading if you're interested in those integrity hashes, how they work, what they do, etc., etc. Okay, so how to generate them. There's also websites you can go to which will generate the hash for you if you want, but I found it's very handy to have it within my rake file within itself. Okay, and then lastly, I love this website. Can I use? So it tells you, for example, can I use content security policies? It tells you all the browsers and which versions of these browsers support content security policies. So you can see nowadays, stupid Internet Explorer. So apart from Internet Explorer, which still uses this really ancient X content security policy header, all of these other browsers support these headers. Opera Mini does not. It supports content security policies. Now, I believe the secure headers gem that you're using, I believe that gem, if it detects that it is um, Internet Explorer, it will set up the correct header for it. It'll set up the content security policy in the X content security policy header. I think. You may have to double check that, okay? But, and by the way, can I use, you can type in any of them. Same site. Oh, excuse me. Same site. Oh, it found it. Can I use the same site cookie attribute? That's this attribute that I set up in my security.rb. Okay. But I found later I had to go back to environments.rb and set it up again explicitly. HTTP only, same site strict. Um, excuse me. And that same site directive passed through the when cookies are sent. Does everyone support it? Again, stupid Internet Explorer does it some other weird way. I don't know how exactly it does it. Opera Mini doesn't handle it. Dangerously, there are some browsers for Android which do not support it fully. All right. Um, so it is still possible some people are vulnerable to it if they're using a relatively not security conscious browser. All right. But I'm so happy that, like when I started teaching these browser side policies several years ago, this list was a lot more red than it is now. It's a lot more green today, so I'm very happy. I used to have to tell students, please do this. It'll be very important in the future. And luckily, after 1 or 2 or 3 years, everyone is doing this now. All these browsers are supporting this now. Okay, which by the way is why I get very angry when I go to websites which are like, you have to use Internet Explorer. I'm like, are you kidding me? Or and in Taiwan, a lot of government school websites are like really ancient in their thinking about security, unfortunately. All right. All right. So that's that. So what have we done today? We have talked about how to use digital signing to ensure that the API can trust certain requests coming in from the web application that don't have an auth token, that cannot have an auth token associated with it, particularly authorization routes, which you don't have an auth token yet. And we use public-private key pairs and digital signing to do that. Excellent. We talked about digital signing way in the beginning, well, maybe in the 4th or 5th week of this semester, and we finally getting around to actually using it in our code. All right. Browser directives. So we talked about how to use certain X dash headers and cookie directives and content security policies to secure the access to control the browser's behavior and policies. And lastly, we talked about using hash digests to ensure that CDNs are delivering the right assets to us and not delivering fraudulent assets or cracked assets to us. Okay, I call these all client-side protection, client-side security, and I think they're extremely vital. Without this, it's like guarding your whole house and leaving the front door unlocked. So it's extremely important that you do all these things all the time. All right, cool. And this is the final picture, my God, of many, maybe not all, but a lot of the things that we have done this semester. It's a crazy busy picture. What did we do? We kind of set up this like distributed application, which is running, on a browser, on a web application, on a web API. It's using a third-party APIs for single sign-on and using OAuth. It's got a database that we had to encrypt and secure. We are storing session variables in a distributed form in a session store. So if we scale up our web application, they can all access the same session store. We were using Redis. We switched to using Redis S protocol, the secure protocol, and also encrypting the resources stored on Redis on top of that. All right. We used tokens for validation. So we learned how to create tokens that could be sent around to other applications, including email clients through SendGrid, and to validate users to see who they are. That allowed us to create accounts. That allowed us to not create accounts until the email was validated. Then that token has all the information, the username, not the password, but at least the username is in that token, so we can go ahead and create the resource later, right? We used cookies, but what we saw is the best way to use cookies is just to kind of store a session ID maybe, and store the actual session information in a session store that cannot be.
Oops, excuse me. Um, Hold on a second. My microphone seems to have died. I think actually my Bluetooth died for some reason. Please give me a second here. Okay, I think I'm back in business. Can you hear me clearly? Thumbs up. Can you hear me clearly? Oh, huh. um, okay, can you hear me now? No. Okay. How about now? Can you hear me? You can hear me now. Okay, great. My Bluetooth, all my Bluetooth devices died for a second for some reason. So my mouse got deactivated. My who's who's hacking into me right now? Okay, all right. Maybe my wife. I don't know. So just to kind of continue the story while everything keeps working for a little bit. What else did we talk about? So we talked about cookies, we talked about auth tokens, and the auth token stored in the session store has full scope, has full power, but the auth tokens that the user can get through the web application, through their account portal, for third-party services to use, basically an API key, that was an auth token with limited scope. So that was something we implemented last week. So please get that working as well. And today we kind of, and also we set up HTTPS between all these things, including, I forgot to draw including to the session store. So that's something we added later on. And then today we talked about how to secure, how to do digital signing between the application and the API, and how to use HTTP headers and cookie directives and content security policy to secure the browser as well. Okay, and then finally how to use the the hash digest to check the integrity of the resources, the assets. Okay, I think for some reason my earphones refuse to work. I don't know why. So excuse me if the sound quality has gone down a little bit. All right. Has the sound quality gone down a little bit, or is it still the same? Same or down? It's a little louder. Same. Okay, great. Okay. So my computer's microphone is not that bad. Okay, louder. Oh wow. All right. This is so weird. And my AirPods are connected again, so I don't know what's going on with my computer. Let me finish up. Hold on. Okay, so I'm gonna try this without my AirPods. No, the power is not low. The power is still got 50% power. My Bluetooth is going crazy though. So I'll try to do this without. Yeah, I could turn on, turn off the Bluetooth, But let me just finish up the lecture and we'll deal later. So I hope you can still hear me clearly, okay? So this is everything we did this week, this semester. So what did we add this week? This week we added the, cross-site scripting and cross-site resource forgery mitigation, combating those threats. We use digital signing both to authenticate the application to the API, and it's also a form of non-repudiation, okay? If a client does make a request, like make an account for me, change the password, something like this, we have a signed request coming in so we know which client did it and we can contact that team and say what's going on. And then finally, sub-resource integrity with a resource hash. This is all the stuff we have done this semester. It's a pretty packed slide. I can't even select it all, okay? So it's a pretty packed slide. All these things that we have done this semester. It's been a crazy semester, and COVID even hit us in the middle of it all. So thank you all for your patience. I'll just take a few moments to talk about what we're going to do next week. All right. So let me open up. I'll send you some more information about what you have to implement this week in terms of digital signing and the browser security. The digital signing may take a little bit of time. The browser security, you almost literally have to copy and paste my security file. That's it. Maybe modify your environments.rb a little bit. Okay. So next week, this is the kind of regulation. So let me just kind of discuss it a little bit. Oh, what's going on? All right. Sorry, everything is acting so slow, and I've got to hide a few things. All right. So next week we're going to be presenting. Okay, so it's the ship it and show off week. You have 20 minutes to make your presentation and 5 minutes for Q&A. Please share as much of the presentation responsibilities amongst your teammates. What are you presenting? Please have a presentation ready in a Google Slides format. I'll tell you what's going to be on the presentation. So use Google Slides and make your slides viewable to anyone who has the link. Make it public. Viewable, not editable, okay? Go to your team spreadsheet and make sure you have links for, let me just kind of write here, all GitHub plus Heroku plus Google Slides. So for your web application and your API, provide us the URLs for the GitHub and also the URLs for Heroku so we can go run it on Heroku. Provide us a link for your final presentation slides. The presentation you're going to make, so use Google Slides for your presentation. Please introduce your project, what's it about, I should write, please introduce team plus, don't spend too much time on your team. We should know who you are and the purpose of your project, okay? You must run a live demonstration of your project in class on Heroku, not localhost, okay? In class on Heroku. Show us all the major features. You must, as part of your demonstration, show us that you can create an account and log in. It's fine to use single sign-on if you want to save time. Okay. It's okay if you create another account with resources already added to it, but show us that you can at least create a new account as well. Okay. You must create resources while you're logged in. At least one resource you must create while you're logged in, and you must show that you can share resources with other users. Okay, remember that was one of the guidelines of this project, is you must be able to share resources with other users. Okay, and tell us if there's something else your application does that's beyond what we talk in this class. Don't spend too much time on the architecture, because I imagine your architecture looks like my architecture, and this is not an architecture class, but do show us a diagram of the major parts. Tell us a little bit about your data schema if it's interesting, but don't spend too much time. Tell us what policies your team had to create. You could spend a little bit of time if you have some interesting policies you want to discuss, okay? But for the most part, don't tell us stuff that is already in my Credence application. Tell us what's different about your application. So once the demonstration is over, tell us what aspects of security you are the most proud of this semester, okay? Tell us what advantages your system has over other applications that may be similar to it on the internet. And then tell us what you can do in the future. Like, tell us, what new features you might add, what security challenges you might have to do in the future, so on and so forth. Okay. Please, while other teams are presenting, I want to see all of you are paying attention, have your webcams on, and show us that you are paying attention to what they are doing. Do not spend that time discussing with your teammates. Of course, this is something harder to do now that you're all online. So, but in class, it would really upset me when students are like talking to each other, trying to get their own presentation working. That's not the time to do it. Not in class, okay? After each presentation, I want each group to be able to have at least one question for each team. So I would like the groups to be able to think on your feet and ask an interesting question to the team about their security, about the project, about the future growth, or things like that. So please pay attention to each other's presentations and ask a question, okay? Great. All right. That's it for now. So please implement the stuff I described today, get the rest of your project working, make sure we are up to date, and post a link on your team spreadsheet to your final presentation as well. And the TA and I would also like, after the demonstration is over next week, we would also like to go into your application, log in, create accounts, and play around with it a little bit, okay? So make sure it's up and working on Heroku before the demonstration, all right? Any questions? I'll wait a couple of minutes to see if there's any questions. You're good otherwise? Okay, great. So with that, that's enough for today. See you all next week. I'm kind of sad that we have to do the presentations online. Usually we like to have a pizza party or meet in a bar or do something crazy. Unfortunately, here we are living under COVID. How terrible. So let's make the best of it. Let's have a good experience. Let's share what we're doing, okay? All right, great. Thank you all very much. Feel free to message me. Enjoy your lunch, and see you next week. Same time, same place, okay? Bye-bye.